The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. Inside Analysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com.
InsideAnalysis.com.
And now, here's your host, Eric Kavanaugh.
Oh, yes, indeed, folks. Welcome to the future. The future is here already. That's what William Gibson once wrote. It's just not evenly distributed. I have to say, I heard that line years ago, and it just blew my mind. I was like, what? That's pretty cool. The future is here already. It's just not evenly distributed yet. But that's happening right now. You see it with cell phones, for example. You see it with certain kinds of construction, skyscrapers. You look at the new skyscrapers in places like Dubai, in the UAE, and they're just amazing. And that is the forefront of the industry. And it's primarily because they have a lot of money. They want to build some cool buildings. And in the rest of the world, you have older buildings that are still standing, obviously. But I bring in this metaphor just to point out that we are at a very transformative phase or moment in time as human beings, quite frankly. And with technology, of course, it's always out there improving, usually improving our lives, doing cool things for us. Well, artificial intelligence, it's not new. It's been around for decades, 50, 60 years, if you really push it all the way back even further, depending upon your definition. But in terms of widespread adoption and use, boom, we are in the middle of that first major explosion. And you can thank the folks at OpenAI for sure with their chat GPT, which just blew the doors off. Now, that even isn't all that new. GPT's been around for a number of years now, but this version that they unleashed on the public really opened eyeballs, and it forced the game. It was a forcing function. But I have someone on the show today who knows a whole lot about AI and has known a lot about AI for a long, long time. And he taught me a lot about this stuff too. Usama Fayyad. He's got a company, Open Insights, but also he was the chief data officer at a company called Yahoo. Some of you all may remember those guys. They were the center of gravity in like the 90s and the early aughts. That was where you wanted to be as an engineer, as an AI person. And then, of course, it kind of shifted to companies like Cloudera and Google, of course, and now OpenAI. But they're still out there. Yeah, he's still doing cool stuff. And so is Usama Fayyad. He's now the executive director for the Institute for Experiential AI at Northeastern University. Usama, welcome to the show here. Thanks so much for your time and attention. And first of all, tell us about the Northeastern University Institute for Experiential AI. Where did this idea come from, and what's your focus?
Thanks, Eric. Idea came from the president of the university, Joseph Aoun, and the provost, David Madigan, who's actually a well-established statistician and AI expert in his own right, and some donors who gave some large grants saying, "Hey, AI is going to be big." This was 5 years ago. So around late 2000. They started saying, okay, we've got a lot of funding, let's recruit for someone to head it up and define it. The way and I'm the inaugural executive director for this, as well as joining as a professor in the computer science college, the Khoury College for Computer Sciences. Mm-hmm. So experiential AI, the first thing we need to do is name it. And we use the term experiential AI to mean AI with the human in the loop. Because the reality of my exposure to AI through my work, whether it was with Microsoft, NASA's JPL, my own startups, Yahoo, later with Barclays, and definitely with Open Insights, working with many companies around the world, including AI in the healthcare space, etc., has shown me one theme that is constant, which is every working AI has a huge element of the human in the loop. Whether you're talking about the core of the Google search engine, or we're talking about OpenAI and ChatGPT and any of these large language models, a lot of feedback all the time from humans, supplying what AI cannot supply. And we, like you mentioned, we've spent over 7 decades trying to figure out stuff like common sense reasoning. one of the big learning lessons is you only can get that from humans today. You cannot get a
Wow.
machine or an algorithm to provide you that feedback, which is why there's a lot of human in the loop intervention in the operation of AI. The other, and that became a theme, because what it means is you need to think about how AI help human intelligence and how human intelligence helps machine intelligence or AI become a reality. So it's about kind of the collaboration with algorithms and robots and so forth. So that's how we defined it. And then we had to go look for, okay, what are areas that need focus, where as an institute, we can make a large contribution, we can become the leader in certain areas, and quickly identified responsible AI as one big area of focus from a research perspective, defining what it is, how do you do it, how do you do risk assessment, etc. And then we also identified kind of what I like to call new generation large language models or new generation generative AI. So how do you reduce this obsession with larger and larger parameters in the model, larger models that can so easily go out of control, start making errors, hallucinating, as Google calls it, or basically are extremely expensive to train, because the more parameters you have, the more expensive. And of course, capital equipment wise, the training infrastructure and the inference is. So rather than how can we make models bigger, the question is, how do I get away with the smallest possible large model and enhance it by stuff that we know, prior knowledge? Do I have a knowledge graph about the domain? Do I understand who the people are? Professional graph, a citation graph, etc. It is silly to try to let the AI rediscover from pure data, very detailed, very expensive data, what we already know. So can we supplement this? And we call this better together. And then we picked certain areas, and we are seeing better results indeed, qualitatively and quantitatively, when we apply these two things together. Finally, we had to pick kind of areas of focus for applications, which is critical for us. So applications, in my opinion, have been the driver in the developments of AI for the past decade or more. So we looked at applied areas in AI plus health, AI plus life sciences, drug discovery and molecule design and things like that, antibody design. And then the last area we added was AI for climate and sustainability. How do we leverage the new generations of data sets that are kind of hyper-local, very detailed, huge big data, if you will, in the world of climate, and then use it to model both the climate and the environment and predict things like, here are the impacts of a potential disaster or a change or what have you. So these areas define where we work, and to drive the wheel forward, to start the flywheel going, we created the AI Solutions Hub. One of the big funders of the Institute is Dave Rue, who funded also the Rue Institute up in Portland, Maine. In order to change the economy in Maine, and AI in his vision was a big area. So we created this AI Solutions Hub, which is a team, a delivery team of data scientists, data engineers, AI practitioners, whose job is to engage with our partners, companies, organizations, governments, and work on real challenges in the real world in order to drive that activity, figure out what the real research agenda should be, and at the same time, figure out how do we train our students and the corporate learners on AI in the wild, AI happening in reality? What are the real issues? How do you deal with it? You know, we all know that dependence, deep dependence of data and generative AI, on data. But the real issue here is, what do you do when the data is not in idealized circumstances? It's got quality problems. Half of it is missing. A third of what's there is wrong. But you got to make the solution work, and you got to make it work in the constraints of kind of real life and real businesses and real regulations and so forth. So all of this coming together gives us, if you like, the active lab that generates the research agenda and generates the chance to train our students and learners from the corporations on how to make AI solutions work.
Yeah, I really love the vision here, because you're appreciating the importance of research but also the importance of training, the importance of understanding use cases, hence the solution portfolio or the solution hub. And, I want to drive into one key issue here that you brought up, because I think it's the most important one to make this stuff enterprise ready and business ready and consumer friendly, which is the truth, right?
Yeah.
We have one of our regular listeners, Alex Husky, super smart guy. He works for ExxonMobil. He sent me an email. We did an webinar a few weeks ago. He said, we cannot allow these large language models to pattern recognize their way to the truth. And that's kind of what they're doing, is it's basically a pattern recognition engine that predicts text based upon the prompt and all the corpus of text that it has consumed. Well, you mentioned citations, for example, and this whole concept of embeddings comes into play. And that's what you need, right? That's the ground truth. Our citations, this is where I got the information, so you can verify that it's correct. That's a cornerstone of making this stuff doable and workable for business, right?
Absolutely, absolutely. And citations are a beautiful example. This autocomplete technology that we call large language models, it's trying to, build its output a token at a time. And a token
Right.
is part of a word, part of a group of pixels, depending on what your output looks like. Well, trying to recollect a precise citation based on an autocomplete is a very dangerous exercise and rife with room for making an error. You could get the year wrong, the author's wrong. You could make up, you could come up with a title, you could change the title, all based on your recollection. Well, why do all that if you already have these citations in very precise format? How can
Right.
you use them? And then tying the citations to the content, to the meaning, is the other big challenge, because most of these models, I mean, we call them technically stochastic parrots, because they really parrot out. They don't know anything. They don't understand what they're saying. So tying that to kind of the sources of truth, as you say, is another huge challenge, which doesn't exist today.
Mm-hmm. Well, and also we have to realize there is a workflow to these models. And what I'm learning from folks is you can do one of two things. Basically, you can fine tune your model by embedding your corporate data into the model, so training the model itself on your corporate data. Or the other very common use case is to use a vector database, and that's where you store your embeddings. And so embeddings would be your financial reports for your business, or your training modules, or documents related to some process in your business. You want to populate all that and ideally just use the large language model for its text generative and syntactical knowledge, essentially. So you're using the engine to spin up the words, but the facts, if you will, come from the embeddings. Isn't that the general idea?
Yeah, and well, you're touching on some of the more interesting aspects of large language models. So let me start by saying, first of all, no one understands why they work. No one has a good explanation of why a very large model that traditional statistics would tell you should never work, because it's over parameterized. It's got too
Right.
many degrees of freedom. It can fit the data and therefore no chance of learning why it works. That's one interesting mystery, right, that we don't understand.
Right.
The other mystery is this whole embedding space. Why is it that if I took a group of words or a group of sentences or a group of paragraphs and mapped them into this very large vector space, which is what's called embedding, a bunch of numbers, basically.
Right.
Why is it that those embeddings capture something about the domain that allows you to generalize, that allows you to build on knowledge? So that representation is another mystery, Eric, that we have people working on trying to demystify and understand what the heck is going on. Those two aspects are some of the deeper aspects of the technology that represent an academic and research challenge, trying to understand what's going on and how do these models work. Fact is, though, they work. And therefore, how do you best leverage them? And then how do you add these embeddings with the other generative stuff, which is straightforward and well understood, the autocomplete technology, if you like, that kind of takes an input, a prompt, and produces the output. The other thing that I'll mention here, which is the third big mystery in the field, is the prompt themselves. How do you come up with the right prompt? We know there's a super high sensitivity between prompt variations and output variations. So small disturbances of the prompt may produce a completely different answer. Some people claim that, hey, these are the new hot jobs. There was a New York Times and Financial Times articles on this is the highest paid jobs, new hottest jobs. My colleague and a core member of the faculty of the Institute for Experiential AI at Northeastern, Byron Wallace, summarized it very nicely in our recent conference where he said, this is not prompt engineering. This is more like incantations and black magic, right? And you know, you might stumble on the right incantation, you might not. And he has a field of study that has to do with, okay, how do we reduce that dependence? How do we reduce that sensitivity? Because at the end of the day, to make it practical and useful, you can't have this huge variation and kind of weird stuff. And he says incantations because sometimes prefixes to prompts that you and I might think have nothing to do with it end up being very useful to guide the model to the right space. So it's people are adding weird stuff in the front and in the end of a prompt just to make it work right. And that is not a science, that is not engineering. We got to figure this out.
That's funny. You know, I'm gonna close this opening segment here with a fun story and basically say that this is not as crazy and different and unique as some people might think. So I had a business partner for a number of years back in the year 2000. And I think earlier you were talking 2000, you meant 2020, I think, when they started this whole thing. So it's 5 years ago. But back in 2000, I was working for a company, Kimja.com, a couple Russians. And the good Russian was named Nikolai. Nikolai Menchikov. He talked like this. One day he said to me, the funny thing about the web is that nobody know how it works. All we know is it works. Right? And it's the same thing. So now what's interesting is if you look at internet and cloud and hybrid architecture and all this stuff that people are talking about today, containerization, Kubernetes, all that stuff. Well, what happened is Google came along with Kubernetes as this orchestration layer to sit on top of Docker as a way to containerize applications, make them really, really small, which is like the vision of service-oriented architecture, but a different bus, if you will. And what's happening is now we have all this data. We have tons and tons. It's called observability. So what's happening now is we're finally starting to kind of figure out how the web actually works. I'm not saying we didn't know anything, but there are a lot of stuff that we didn't really fully understand about how the web actually works, like which ports are important in what particular process. I mean, there's all this stuff going on. So my point to you is that this AI stuff, you're right, we don't know how it works. It's not the first time we've found some engine that works and we're like, well, we don't know exactly how it works, but it sure does work. But folks, don't touch that dial. We'll be right back talking to Usama Fayyad of the AI Institute from the Experiential AI Institute. We'll be right back.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
All right, folks, back here on Inside Analysis, your host, Eric Kavanaugh, with Dr. Usama Fayyad from Northeastern University's the Institute for Experiential AI, which basically just means humans in the loop. Humans are really important. Even with self-driving cars, you have to give correction to the vehicle. I've actually driven a couple of these now, and it's kind of freaky when it starts taking the wheel from you and like, whoa, what are you doing? I didn't even know it was self-driving. It was a rental car. I'm like, oh, what's going on here? Oh, okay, it's taking over for me and saying you shouldn't be doing something. We're getting there. It's, I mean, thanks to innovations, thanks to Elon Musk and Tesla and all these innovations those folks are doing. Pretty cool stuff. But Dr. Fayyad, we wanted to dive into the critical success factors. And one absolutely positively is the data. You know, I keep cautioning people, and we're going to probably dive into this more in our own business of consulting with organizations. Be very careful how you train your models. You want to train your model on your data. You want to give it curated, trusted data. You don't want to just point it at whatever information system you have, because there's a bunch of junk in there. And anyone who's ever done a data quality initiative knows that if you get an executive who doesn't believe the data is crap, just show them, just open up any database and point to any corner of it, and you'll find some problem somewhere. I promise. It's just everywhere, whether it's data in the wrong fields, data in the wrong format, data that was truncated during some ETL script or something, and it's just everywhere. There's bad data everywhere. So getting the right data is really important, Dr. Fayyad. How do you do that? What do you recommend when people come to you and ask you, what are the best practices? What do you tell them?
Yeah, great question. So data is a whole ocean to open up. I mean, there's the collecting the data at quality. There's collecting data at the right level of granularity. So we have spent decades, as you well know, Eric, in the whole area of data warehousing and kind of information systems management and so forth, and data management, thinking about data for use by humans. Now, what the AI has, the AI first companies or the companies who really are using AI today, they have a deeper understanding that, hey, machines need data at a different level. They need high granularity, not necessarily stuff understandable by humans, but every little detail of what happened, every log of every event, every kind of intervention, correction by a human, etc., captured. This is not how most organizations or companies work today. So that is one big shift that needs to happen. The second thing is, if you notice, a lot of the literature and lore in the world of data has to do with structured data. Well, according to Gartner and many others, the majority of data in any organization, in any company, is actually unstructured data.
Right.
If you actually talk to the IT teams and the technology teams and so forth, they typically only know how to deal with structured data, and then they hit unstructured data, they're stuck. It's like deer in the headlights. We have to change this dynamic to understand that, hey, we got to embrace the unstructured data, the text, the images, the video, the audio, interactions in the customer center, all the conversations, and leverage that information properly. And that needs, there exists many good tools out there. Most of them also, fortunately, are in the open source, which is something I'm very big fan of. But you can put these things together in solutions that work for businesses. And this is something we're very passionate about. How do we partner to figure out how we help our partners figure out how to approach an area, how to capture the data, etc. Now, that leads me to another very, very important data that's information or aspect that's very related to data, which is kind of many companies out there think that all we have to do is wait for Microsoft or OpenAI or whoever to refine their models so that they can meet our needs. What happens then is you become users of the technology. You don't have your own private language model. You don't have the ability to capture all these corrections. You mentioned corrections when you're driving, right? Well, it's great to intervene and correct, but if you don't capture that correction, the context for that correction, why you made that correction, your model is never going to benefit from it unless you're willing to share it back with the company who's providing this public utility, this large language model. Often this information is sensitive, it's proprietary. I argue it's one of the most valuable sources of IP that any company operating in any space has, which is kind of the secret sauce. How do our processes work? Where do we intervene? Why do we fix? What is our way of doing things? Today, companies let all of that go into the exhaust by never capturing it. In reality, you need to be able to not just capture it, but feed it back. And feeding it back leads us to another whole interesting area, which means you really need to have your own private language model.
That's right.
That model can't be too huge, like the likes of OpenAI or ChatGPT or any of these. It has to be as small as possible to maintain its stability, to maintain its maintainability and its reliability and so forth. But it needs to get feedback. So you need to be able to capture all that feedback, all those corrections, and feed them right back and retrain that language model in an affordable way to maintain your own IP, your own knowledge, and so forth. Now, many of the companies who offer the large language models will offer you the chance, of course, for money, to kind of fine-tune the model or create your own tuned version of the model. And there we can talk about technically what happens. All they do is they cut off the output layer, they throw it out and retrain an output layer. They call these adapters. That is kind of fine-tuned just to your problem and on your feedback. But that we know that that's less effective than retraining the model and reintegrating that data into the whole stack. So coming up with a large language model, your own private language model, is not impossible. It is very doable. Many tools are available out there, whether you're talking Falcon, which came from Abu Dhabi, or Llama. Well, Llama 2, I'm a big fan of at Facebook or Meta, because they actually, not only did they make it open source, they gave a commercial open source license. So companies...
I saw that, yeah.
And that opens up a whole other approach and a whole other mechanism. But to do that and to take advantage of it, you need to have the talent and the know-how of how do I use that language model? When do I fine-tune it? How large does it have to be? How small can I make it? All of these questions are the kinds of questions we partner with companies on kind of answering and figure out what is the right approach here in this very, very confusing, and I might add, fast evolving space. I mean, I try to keep up, and I am challenged, right? Every week, every month, there's new innovations, new ways of doing things. Somebody's scrapping something old and saying, ah, it didn't work, actually. It was a part of the system, but now we got to do something completely new. All good, all healthy, but it's a challenge to keep up with the latest, greatest, and the right best practice of how to use it.
Yeah.
Start with, I just want to remind everybody, that data that you're letting go into the exhaust by not capturing it systematically, that is gold. That is
Yeah.
actually more valuable than gold. It's not just oil, it's more valuable than gold. And you're letting it go out in the exhaust and losing all that IP that your teams, your employees are working on day in, day out in keeping operations going.
Yeah. Well, I just as you were talking, I thought of an interesting metaphor here, and I'll throw it at you. I think you'll find it interesting. So think about language and feeding a dictionary of English to something like one of these large language models. You feed it the dictionary, it knows all the different words, but people don't talk the way they write. And people don't talk the way dictionaries are written necessarily. There's a lot of slang, there are lots of expressions, idioms, all these different things that don't fit neatly into the definitions of words, but it's how you actually speak when you're talking to someone. And that's the unstructured data, really, or that's the unstructured syntax almost of how people actually interact with words on the phone, in person, in certain cultures and in certain regions. And so if you don't absorb that contextual information, your engine will never speak like a normal person does, right? So this is the nuance you have to appreciate, is that what's on paper often is very different in the spoken word. What do you think?
Absolutely, and it's critical in many applications. Actually, I would argue in most of them. If you're dealing with conversational AI, if you're dealing with humans, whether you're doing it for marketing purposes, whether you're doing it for customer service, whether you're doing it for predictive maintenance, and it's not only kind of the idiom or kind of how the public or the customer speak. It's often the culture within the company. Your engineering team has their own terminology where they use certain terms. If you look
Right.
them up in the
Right.
dictionary, they mean something completely
Right.
different, but they're used in the company to mean a certain
That's funny.
aspect of a process, a certain aspect of a system. Learning all of that and making it work in the right context is a real interesting challenge. And it's very possible. I mean, that's why I describe it as gold or more valuable than gold, because it contains all these instances and it gives you the keys to allowing these systems to have the bigger and correct impact on how you do acceleration, how you do automation, how do you leverage generative AI to kind of give you that unique competitive advantage out there. I've experienced it personally in healthcare, right? If you're in an operating room or in an X-ray room or in an imaging center, the language being used is completely different than what's being used in a pathology lab or a practice for physical therapy or what have you. So all of these things, all of these aspects are important. What context do you use the words in, what they mean, new meanings that are not available in the dictionary, all of that
Right.
is so important and so critical, technically
That's right.
and socially and marketing-wise.
Yeah. Well, and there's also tone of voice. I mean, I remember going all the way back to like third grade or something. Our teacher asked us a question and it stumped all of us. And I thought about it later. I was like, oh, tone of voice. That's what he was talking about. You can say something and mean it honestly, or you can say it sarcastically. And usually it's the tone of voice and the context that will tip off a human being. But it's going to be harder for a machine to understand that. But not if it has the intonation, not if you capture the audio and it can kind of pick up on that sort of thing. But these are the sort of deeply understood aspects of communication that we just know as grown-ups that we've learned over time. I mean, I remember, and this is funny, but probably most people don't remember this, but I remember the first time I really experienced sarcasm because I was like 2 or 3 or something, and I'd spilled milk, and my mother, and I knew it was a problem. I was like, oh no, this is bad. And my mother looked at me, she goes, well, that's just great. And I was like, hold on. I know that great is good, but that tone is not good. What's happening here? And I was really befuddled as a child, but that was my first experience with sarcasm, right?
I'll give you, Eric, here, you're touching on one of the biggest challenges that, for example, search engines today face, which are memes, right?
Right.
You hit a meme on the internet, the search engine thinks it means one thing. Reality is it's something completely different. And the only way you catch that, today is human intervention. Search editorial teams saying, wait a second, this shouldn't be in your search result. This is a meme. It means something completely different. It has nothing to do with biology or whatever. It's being used to refer to a group of people or a group of practices or what have you.
That's
so
funny.
those are real things that matter a lot. And you have to have mechanisms for catching them. And in a way, you can argue that a lot of the internal culture of a company's operations team, a company's engineering team, a company's business team, a company's sales team, a company's marketing team is filled with these memes. We don't call them memes, but they are there.
That's funny. There's actually a great Seinfeld episode where George Costanza, he's working for the Yankees, and I think he was talking with it was like the Texas Rangers or something, and it's a baseball team, and the culture of the executives for that team loved using curse words. So they were insulting each other all the time, but as a compliment. And then George's boss walks by as he's on the phone using all these expletives, and the boss is like, oh no, what are you doing? This is terrible. In reality, he's bonding with these guys because the context was there. Classic dramatic irony, right? The one guy didn't know the context, but this is the importance of nuance and understanding context. And to your point, just getting it back to training AI, your own private language model, which is what most businesses are going to want to have. I'm pretty sure you have to bake in that kind of stuff. You have to have that human in the loop that goes, okay, no, this is an example of sarcasm, or these guys are just being goofy or whatever. In their context, calling you a jerk or a so-and-so is actually a compliment. That's the human intervention part, right?
Absolutely. And I remember that episode, but the thing I wanted to mention is, language, the language use is very different than kind of the formal language defined. And that is why I believe, like you, most companies will find out that to achieve true competitive advantage, to have differentiation, you're going to have your own private language models, which opens up a whole new area. We're a company that's in the quick service restaurant business, or we're a company that's doing manufacturing. What do we know about large language models, AI, etc., and how do we approach it? And part of this demystification and kind of working with you on the AI journey is one thing our institute is very passionate about, because that actually puts us right up front on the front lines of getting the applications to work and helping our partners getting it to work. And through that, we will learn what the real research problems are, where the real challenges are, and we will learn what should we be teaching our students and our corporate learners in order to be effective in that world. So that whole area of the infrastructure, the talent, the know-how you will need to build your own private language models, to capture your own IP and your own knowledge.
Right.
It's going to be a whole huge new trend that no one out there is paying attention to in the business world. They're focused on being users of these public models.
Right. No, that's a very, very good point. Well, folks, we're talking to Dr. Usama Fayyad. We'll be right back. Don't touch that dial. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
All right, folks, back here on Inside Analysis, talking all about experiential AI. That's humans in the loop with Dr. Usama Fayyad of the Northeastern University Institute for Experiential AI. Got to get that all clean and straight in my head. The Institute for Experiential AI. It just means humans in the loop, basically. But we're talking about the power of these models, which is amazing. We're talking about how a lot of people don't really know how they work, including people who design them. We just see that they work. And so we're coming up with strategies to help companies really harness the technology. And I think that's the key, right? If unbridled, this thing will go wacko and cause you all kind of trouble. But if you harness it effectively, and that's your governance structure, it's your embeddings, it's using ontologies. And I mentioned my friends from Praxi Data who are using ontologies to really narrow the focus of their work and thus be able to deliver some tangible business value. And, that's always been the case with machine learning and AI is you have to have a very narrow focus and you have to know what you're trying to accomplish. I mean, you can use deep learning to discover things, but even then you're trying to discover things. So you have to have a purpose and a mission and an objective upon which you train these models to be able to understand if you're getting anywhere, right? Tell us a bit about that and why ontologies matter, Osama.
Well, I mean, ontologies give you the basics of understanding domains. There are many things you have to worry about. And by the way, not coincidentally, a lot of the work in generative AI now is using what we call the RAG framework, which stands for Retrieval Augmented Generation, which is another form of kind of enforcing the model to stay within certain guardrails and to say, here is what we mean. And it's aided by kind of retrieving the right references and all that to help it from straying, both in training and in answering. But anyway, working in different domains, you need to figure out ways of bringing in that domain knowledge, that domain into the problem in order to constrain the space, in order to focus it. I was talking about the secrets of making AI work, and we talked about the humans in the loop are a must, interventions are necessary, data at the right level is absolutely necessary. Most data is being lost. But I will add the last bit is, how do we bring in known domain knowledge, and how do we narrow the problem down to a very narrow, very specific problem? Because trying to solve AI in general has proven to be an impossible task, a very difficult task for the past 7 decades. And it will continue to be that. And our best prescription for fixing it is by narrowing the problem and resorting to what we call narrow AI versus general AI. General AI is still far out of reach. Narrow AI has worked and has been working for many years and decades, actually, in different domains. And the key there is domain knowledge. The key there is narrowing it enough so you know that not every possibility is here, and you don't have to worry about every language, and you don't have to worry about every variation and every meaning. No, restrict yourself to this domain. Here's what things mean. Try to get complete knowledge around that domain. And that's a secret of making it work. That only comes by figuring out what are the use cases, what are the domains of applications, and how do I come up with a methodology that allows me to build solutions for each specific use case, which is why we kind of focused on things like AI plus health. How do we get healthcare applications into AI? How do we leverage digital health? We live in a world today, think about at the highest level. You go see your doctor, hopefully once a year, maybe twice a year, right? Only when something is wrong, other than the routine visits. And what happens between these routine visits is a total mystery to the provider, to your physician, because who knows what happened to Eric during this 1 year. Now Eric needs to fill me in. And who knows whether Eric can fill me in completely or skip a whole bunch of important things. Well, guess what? We live in a world now where there's a lot of instruments. We've got these watches, we've got the mobile phones, we've got the, all sorts of devices, cameras, other things in our homes that can actually capture a lot of the information that typically is only captured in a clinic. So how do we leverage that to close the loop at the highest level? And that we call that digital health. Another form of digital health is things like oncology, or actually more generally pathology. How do we bring these digital techniques down to a pathology lab where somebody's taking a sample, looking at it in a microscope, and kind of storing it in this glass slide? Well, guess what? Digitization can help a lot. You can look at it with instruments and with algorithms instead of just the human eyes, instead of just relying on staff to do. You can try capturing what's happening in the heads of these very talented pathologists who are looking at an image and concluding a result. This happened in radiology in a big way. Radiology has been digitized. It benefits from a lot of these things. In pathology, it hasn't happened. Pathology is still practiced like it was, 3-4 decades ago. It can benefit from a lot of digitization, which brings in a lot of AI and a lot of use of these things. In life sciences, we have many use cases, whether it's the acceleration of drug discovery, How do you design? How do you accelerate the design of the next antibody, right? Antibodies are very effective ways of coming up with cures, vaccines, ways to mitigate disease spread. But it typically takes about 3 years to come up with the right antibody for something. So it wasn't a viable solution for COVID back in 2020 or 2021 because it took 3 years. But if I can get that 3 years down to 3 months by accelerating it through compute and through modeling, amazing things can happen, right? Take things like that happen in a hospital or a physician when you're being taken care of in one of the projects we have is called Heart, which expands to something involving AI. But what it is, one of the applications, and we're working with a large hospital system, is how do you determine when somebody should not be downgraded from critical care? They're in the ICU and things look good. Oh, we can downgrade them. But the algorithms can tell you, no, there's a huge danger here if you downgrade that issues will recur, which is horrible for the patient, horrible for the hospital, horrible for the physician. And you want to make that decision when you're absolutely sure that no complications will happen. Similarly, you don't want to keep them in ICU too long because that's not great for the patient. And it's a use of a very limited resource, the ICU. So a lot of these problems come up in a lot of places. And there with my colleague, Ray Winslow, who's also a core member of the faculty in the Experiential AI Institute, he leverages what's called computational medicine. How do we model these things? How do we model processes? How do we model patients? How do we model diseases? And use those to come up with predictions that are hard to get otherwise. So those are applications in healthcare, in life sciences, and our newest area is the climate and sustainability. How do we leverage kind of new data sources and models, et cetera?
Yeah, and to drill real quick into this the ICU example, which is a fantastic one, I'd like to point out for our audience, and let's get some feedback on this. Send me an email, info@dmradio.biz or info@insideanalysis.com. Both come to me. You know, at any point in time in a workflow, you can insert an AI suggestion, for example, or you can have it sort of waiting to make a suggestion. So anytime the clinician is there and they're typing information, they're doing stuff, as you go to the screen where you're going to think about maybe downgrading this person from ICU, that's an excellent point at which to offer an opportunity for the AI to give a suggestion, right? So it'll come in and say, I see you've just launched this screen. Maybe you should reconsider because of XYZ. And I think that's really where a lot of this AI value is going to manifest, is in suggestions at certain points in a workflow, right?
Absolutely, Eric. And you've touched on a very important area where my colleague, Professor Ray Winslow, who I mentioned, working also with Professor Jean Tunick, who runs our AI plus health area for the Institute, they like to call it, how do I make AI a valued member of the medical team? That word you used, recommendation, is key.
Right.
Because AI doesn't know everything. It may, sometimes it's right, sometimes it's wrong. The feedback from the physicians or the care team, a nurse could be anybody, would be very beneficial to both improve the AI and to allow that AI to contribute to the proper care of that patient. So I love that analogy, which is, AI needs to be just another member of the healthcare team, making its own recommendations and learning from corrections, interventions, or getting it right and wrong.
That's right, and learning. And here's the beautiful thing, Dr. Fayyad mentioned you have to capture all this information. When you correct the engine or when you accept the recommendation, all of that should be captured as well, because then over time you can see, well, Dr. Jones never accepts the recommendation of the AI engine, and Dr. Phillips always accepts the recommendation of the AI engine. Somewhere in between is probably where we want to be. But the point is, we, as human beings, we are actually very predictable. And you will know that if you start looking at your device that's giving you the feedback on how often you are on this app or that app or all these different things, you will see a reflection of your behavior and you'll realize, boy, I am pretty darn predictable. Every day at this time I do X. But hey, hang on for 1 second. We'll be right back after this break. You are listening to Inside Analysis. Okay, folks, time for the podcast bonus segment here on Inside Analysis. Always so much fun talking to Dr. Fayyad, and you made a point there after in the break about the importance of trust and building trust in the system, for the doctors, for the team. Go ahead with that.
Yeah, so I mean, one of the critical pieces of making the AI a valued member of the medical team or the care team is that ability to kind of make suggestions and get feedback. Those suggestions, those recommendations, they get they get evaluated by a physician or a nurse or whatever. They may get corrected every once in a while, which gives them a chance to contribute to the system and its evolution, and they feel that's their baby. But at the same time, they get kind of this incremental exposure to, hey, this thing is right. Hey, it caught something I missed. So it's useful. And by the way, applies equally well whether you're dealing with a medical team or a factory, a team of engineers in a factory, a team of operators in a monitoring center. Every application where the AI can contribute, you need to gain the trust of the users and the domain experts, because that's the only chance you're going to have of getting acceptance, getting important data, getting feedback, and keeping the system healthy.
Yeah, that's right. And what I've noticed about the AI that I've seen in practice, which I see in my email or my text messages and other places, it's like, oh, you haven't followed up on this text. Do you think it was 3 days ago, basically? That's a perfect example of a reminder that is helpful, because let's face it, even the best doctor in the world will forget sometimes to do one little process, one little piece, and depending upon the use case, that could be a very serious thing or not so serious thing. But, you forgot to wash your hands, for example. You forgot to put the mask on. You forgot to put the scalpel back where it belonged. These little teeny tiny things, because guess what? People get distracted. Even very focused people can get distracted. And so the AI is there as your little helper, watching you, making little suggestions along the way, not rapping you on the knuckles, getting you in trouble with your boss necessarily, but just giving you a little bit of a hint and a nudge. And it reminds me of one of my favorite expressions. It's an old cliche, you don't hear much anymore, but and of course it's focused on man, but it means men and women. It said, man doesn't need to be taught so much as reminded, right? We already learned, we just have to be reminded. Final thoughts from Dr. Fayyad. Go ahead.
Yeah, and absolutely, and you actually need both. Learning in the system is also critical, because no system is going to get it right. So every once in a while, it's going to guess the wrong thing, and it becomes annoying. It's reminding me of something I already know, right? Well, I need to give it that feedback. Hey, in this context, don't remind me. And then if it adapts to that, now you have intelligence. Now you have something you value, and it's personalized. So now you want to keep it, because now it's beginning to get to know you and your preferences versus me and my preferences, which could be completely different. So bringing machine learning into the loop and making sure these systems learn and adapt to the feedback they're getting is very critical.
Yeah, this is wonderful stuff. Well, look this gentleman up online and look up Northeastern University, the Institute for Experiential AI. That just means humans in the loop. Dr. Fayyad here, and you folks have put together a great program, and you understand the interplay between training and research and development and solution design. All these things feed each other and will feed each other over time. So you know how to train people, know how to get people excited about stuff, and really nudge them and get them involved, because the humans in the loop, they're the ones who are going to make all this stuff successful and worthwhile, and it's going to save lives in the healthcare space. I promise you, it's going to save lives. It's going to save time and effort. And it's going to do the most important thing, I think, for any business, that is improve morale. When morale goes up, good things happen. When morale is down, good things do not happen. So just
And
ask the Dallas Cowboys.
thank you, Eric, and thank you for getting our mission and vision for the Institute. You got it perfectly.
I love it. Well, we'll talk to these folks again. I am sure, folks. Don't touch that. Wait, actually, we'll talk to you next time. Info@InsideAnalysis.com. Bye-bye.